My name is Akshay and my roll number is 23011A0320 and I am pursuing my second year BTech Mechanical Engineering regular from JNTU Kukatpally. PowerPoint presentation on components of LT switchgear and battery backup. Switchgear. Let us understand what a switchgear is. The apparatus used for switching, controlling and protecting the electrical circuits and equipment is known as switchgear. LT switchgear. LT switchgear is panel refers to the low tension panel that is being manufactured and applied for controlling the distribution systems and power control of AC. There are six components of LT switchgear: circuit breakers such as MCBs, MCCBs, and ELCBs, fuses, disconnect switches, bus bars, distribution boards, and surge arresters. Circuit breakers. Unlike fuses, circuit breakers are mainly used for household purposes. A circuit breaker is an electrical safety device designed to protect an electrical circuit from damage caused by current in excess of that which the equipment can safely carry over current. Its basic function is to interrupt current flow, to protect equipment, and to prevent fire. Unlike a fuse, which operates once and then must be replaced, a circuit breaker can be reset, either manually or automatically, to resume normal operation. A disconnect switch is a type of switching device, visible contacts, used to ensure that an electrical circuit is completely de-energized for service or maintenance. They are often found in electrical distribution and industrial applications, where machinery must have its source of driving power removed for adjustment or repaired. Disconnectors can be operated manually or by a motor and may be paired with a earthing switch to ground the portion that has been isolated from the system for ensuring the safety of equipment and the personnel working on it. Bus bars. A distribution board, also known as panel board, circuit breaker panel, electric panel, fuse box, or DB box, is a component of an electricity supply system that divides an electrical power feed into subsidiary circuits while providing a protective fuse or circuit breaker for each circuit in a common enclosures. Fuse is a simplest and cheapest device used for interrupting the current flow, the overcurrent flow, to reduce the damage for the equipment under short circuit or excessive overload current magnitudes. The action of a fuse is based upon the heating effect of the electric circuit. The fuse has inverse time current characteristics. The part which actually melts and opens the circuit is known as the fuse element. Fuses have following advantages and disadvantages. Let us discuss the advantages first. A fuse is the cheapest form of protection available compared to MCBs, MCCBs. Fuse is the cheapest device available. It needs no maintenance. Its operation is inherently completely automatic, unlike a circuit breaker, which requires an elaborate equipment for automatic reaction. It interrupts enormous short circuit currents without noise, flame, gas, or smoke. And the disadvantages of the fuse are considerable time is lost in rewiring or replacing a fuse after operation. On heavy short circuit, discrimination between fuses in series cannot be obtained unless there is considerable differences in the relative sizes of the fuse concerned. Current time characteristics of a fuse cannot always be correlated with that of the protected device. Battery backup. A battery backup is a system in some power supplies that switches between a main power source and a battery. Battery backup provides emergency lighting in the event of power failure. The battery backup provides uninterrupted coupling of the gas turbine units to the power supply network. A battery backup provides power to a system when the primary source of power is unavailable. When there is loss of primary power source, then the backup gets activated and the current is used from the backup battery. Backup batteries range from small single cells to retain clock time and date in computers, up to large battery room facilities that power uninterruptible power supply systems for large data centers. Small backup batteries may be primary cells. Rechargeable backup batteries are kept charged by the prime power supply. Examples of the backup batteries are in the fields of aircraft emergency batteries, alarms, computers, telephony, telecommunication networks and data centers, video game cartridges, hospitals and power stations. Aircraft emergency batteries. As we know, the main power supply for the aircraft is the fuel. When the engine backup battery in aircraft keep essential instruments and devices running in the event of an engine power failure. When there is an engine power failure, there must be a power supply, a backup power supply to run the essential events such as navigation system, lighting system, airplane control system, etc. Each aircraft has enough power in the backup batteries to facilitate a safe landing. The batteries keeping navigation, ELUs, emergency lighting units, emergency pressure or oxygen systems running at altitude, and radio equipment operational. Larger aircraft have control surfaces that run on these backups as well. Aircraft batteries are either nickel cadmium or valve regulated lead acid type. The battery keeps all necessary items running for between 30 minutes and the 3 hours. Large aircraft may have a ram air turbine to provide additional power during engine failures. Burglar alarms. Backup batteries are almost always used in burglar alarms. The backup battery prevents the burglar from disabling the alarm by turning off power to the building. Additionally, these batteries power the remote circular phone systems that craft phone line snipping as well. The backup battery usually has a lifespan of 3 to 10 years depending on the make and model. And so if the battery runs flat, there is only one main source of power to the whole system, which is the mains power. Should this fail as well, for example a power cut, it usually triggers a third backup battery located in the bell boxes on the outside of the building, which simply triggers the bell or siren. This, however, means that the alarm cannot be stopped in any way apart from physically going outside to the bell box and disassembling the siren. It is also why, if there is a power outage in the area, most burglar alarms do start ringing and cannot be realistically stopped until the main power is restored. Computers. Modern personal computer motherboards have a backup battery to run the real-time clock circuit and retain configuration memory while the system is turned off. This is often called the CMOS battery or BIOS battery. The original IBM 80 through the through to the PS/2 range used a relatively large primary lithium battery compared to later models to retain the clock and configuration memory. These early machines required the backup battery to be replaced periodically due to the relatively large power consumption. Some manufacturers of clone machines used a rechargeable battery to avoid the problems that could be created by failing battery. Modern systems use a coin-style primary battery. And this is the image of the lithium battery, Japan STD. Telephony. A local backup battery unit is necessary in some telephony and combined telephony data applications built with use of digital passive optical networks. In such networks, there are active units on telephone exchange side and on the user side, but nodes between them are all passive in the meaning of electrical power usage. So if a building, such as an apartment house, the losses power, the network continues to function. The user side must have standby power since operating power isn't transferred over data optical line. Telecommunication networks and data centers. A valve-regulated lead-acid battery (VRLA) is a battery type that is popular in telecommunications network environments as a reliable backup power source. VRLA batteries are used in the outside plant at locations such as controlled environmental walls, VECs, CEVs, electronic equipment enclosures, (3BDs), and HUDs, and in uncontrolled structures such as cabinets. VRLA battery string certification levels based on requirements for safety and performance is a new industry approved set of VRLA requirements that provides a three-level compliance system. The compliance system provides a common framework for evaluating and qualifying various valve-regulated lead-acid battery technologies. Power stations. Power failure in a power station that produces electricity would result in a blackout situation that would cause irreparable damage to equipment such as the turbine generator. The best example, the safety of power station employees is a major concern during an unscheduled power outage at a power plant. A bank of large station backup batteries are used to power uninterruptible power supplies as well as directly power emergency oil pumps for up to 8 hours while normal power is being restored to the power station. And the last topic is battery backup in hospitals. Power failure in a hospital would result in life threatening conditions for patients. Patients undergoing surgery or on life support are reliant on a consistent power supply. Backup generators or batteries power supply to critical equipment until main power can be restored. Thank you.